Now, welcome back to our training. Yeah, welcome back to our training. It's quite a long time. We're going to continue from where we stopped on Python. Now, we'll be looking at how to we are going to look at how we can use the Matplot library in Python in creating charts, because in creating diverse kind of charts, the Matplot library comes handy. It helps you to create different types of charts in Python. Tips to create different types of charts in Python. So we are going to see how we can make use of the Matplot library in creating charts. Now, when you have a data point, first and foremost, you want to see the distribution of your data set. And in order to see the distribution of your data set, what you need to do, you have to create a scatter plot. A scatter plot helps to show the distribution of your data set. Now, in the Matplot library, we have different types of packages in the Matplot library. And one of the package is the PyPlot. PyPlot. Now, in a PyPlot, it has different types of function. In the PyPlot, we have different types of function. And one of the function in the PyPlot is the scatter function. The scatter function helps you to plot a scattergram. Now, before you start plotting the chart or you start doing analysis in Python, the first thing you need to do is to look at the distribution of your dataset by plotting the scattergram of your dataset to see how your dataset are related to each other. You make use of the scatter function. Then, first and foremost, we need to import. First of all, you need to have installed the Matplot library in Python. And after that, then you can import the PyPlot. So first and foremost, we are going to import the PyPlot package, which is one of the packages in Matplot library. So first and foremost, import Matplot lib.pyplot. Now, pyplot is a function, does pyplot. Now, that's the function in Python. That's the function in Python that we're going to use in creating charts. So that's the function in Python we are going to use in creating chart. So import pyplot, okay, let's say as flight. Okay, import Python as flight. Then let's import that as flight. If we want to generate a random numbers, we can use the NumPy. The NumPy helps in generating random numbers. But I'm not going to use that. I'm just going to get a set of data. I'm going to get a set of data here. I'm going to get a set of data that we're going to use. I'll just get a set of data. Let's say this is X equals to this. Let's say we have Y. I'm going to get another, excuse me. I'm going to get another set of data. I'm going to get another set of data, which we are going to use. Okay, now you can see the number of data sets we have here is the same number we have here. So this is X, this is Y. We have the same number. Then we said import matplotlib.pyplot. Pyplot is a function we want to use in plotting our chart as ply. So we are going to do ply dot. Now we want to plot the scattergram. We are going to use a function in this pyplot, in this package known as pyplot. I want to use a function known as a scattergram. So dot scatter. Then we use the X, comma Y. Okay, that is it. Then now we have to use apply dot show. Yeah, apply the show has no argument. Then we run that. The variable we run that plots the scattergram. Now you can see that we have from 2 to 16 and 80 to 110. That is our data set there. And we have two there. Okay, just 111. Okay, you can see 1, 2, 3, 4, 5. So y is 1, 1, 11, 1, 2, 3, 4, 5 when x is 2. So you can see when x is 2, y is 1, 11. So this gives us the distribution of our data. So now you can see our data set is it's somehow downward sloping. It's somehow downward sloping, a kind of linear model, but not really linear model, but we have something like this. So if I want to take this model like this, up to like this, I can see a kind of logarithm model, but I can decide to call this as an outlier. As I can see, I have a downward sloping linear model. In other words, the relationship between x and y are linearly what? Related. In other words, when x increases, um, when x increases, y decreases. When y decreases, x increases. So a kind of inverse relationship between the two variables. So we can also plot more charts using the pie plot. Now, so we can also use the pie plot to compare data sets. We can also use it to compare data sets. So we said there seems to be a relationship between x and y, downward sloping and upward sloping. So if x is price, if the y is price and x is quantity, we can see that there is an inverse relationship between price and quantity. As a price, for instance, let's assume that the price of car, as the price of car decreases, more people tends to buy car, or as the price of fuel of car decreases, more people tends to buy more fuel for their vehicle. So we can just assume that to be the kind of relationship between the two variables. Now we can also plot as scattergram. We can look at different set of scattergram. We can have another set of scattergram here, and can have another set of scattergram here, and then we we have another set of scattergram. Let me simply with this. Let me call this X. Let's assume this is for the month of February. Let's assume this for the month of January. And we are looking at the rates at which um car we are looking at the rates at which the the rate at which people buy fuel, the number of liters of fuel that are being bought, depending on um depending on the let's say depending on the month. Let's say this is for the first quarter. Let's keep first quarter. Okay, that's for the first quarter. And we can look at the second quarter. That we are looking at the kind of um the rates, and then okay, let's see, let's say this is the second quarter. Okay, oh, let's see whether that's the second quarter. We're just trying to see, okay, if the prices, now we're looking at let's assume that this represents the prices of a particular product, and this is the quantity that is being bought. In the second quarter of that same product, these are the prices that are observed, and the quantity that are being bought from that particular product. The quantity, let's assume the quantity, we have this. Okay, we have y is equals to, yeah, so we have this, okay. Then let's cut this off. Let's leave this way. Okay, now we have this. Now let's run this. Okay, first quarter. Okay. We are going to, because that is um wait, that's a comment. Now, okay, now we can see, now comparing the two data sets together, we have the first quarter and we have the second quarter. Okay, see, we compare the prices and the quantity of this that is being bought in the first quarter and in the second quarter. Now you can see we do a comparison. But if I had done this here and I did this here and I decided to make use of the slider show and I run this here. Now, okay, running that there, you can see gives me two different graphs. I won't be able to do the comparison very, very well. But doing it this way around helps me to do a better comparison between the first quarter and the second quarter. So now you can see the comparison between the two quarter, the first quarter and the second quarter. So we can also add our own color to each scatter plot. If we want to do that, we can add our own color to each scatter plot. Okay, all what you just need to do is just like at this point where we have them, we can say color is equals to, let's try let's say red. Okay, let's run this. Okay, now you can see it has red here. And we could also give this as part of the argument, plot the scatter. As part of argument, we can add them. We can add, let's say, red. We can add, let's say, yellow. Okay, whichever color you want to add. And we run that. Okay, that gives us the scatter plot and it helps us to color that particular scatter plot. So you can also use if you know if you know the color if you know the color you want to use, you will know that that stands for the color. You can make use of that. If you know that, you can make use of that. Um, okay, once you know the color, once you know the numerical the value that represents the color. Also, you can use what the array of color. You can set your own color marker. You can decide to set your own color marker. For each of them, you can set your own color marker for each of them. Okay, you can set your own color marker for each of them. let's import numpy as I want to use array of color as np. Okay, I want to use an array of color. So I want to use an array of color. So I'm going to use that okay. Let's get this straight. Now I'm going to use an array of color in order to do this. So let me have something like this. Okay. Red. Let's just assume I have something like this. And here I have my color. Um, I have my color there to be uh, um, I have my color there to be let me make this to be okay. Then I'm going to say let's say um um yeah, let's say this t is equals to this. Okay, let's try running this and let's see. Um, let's see. Okay, we have a lot of list objects not callable. Let's see where we are with an error there. Let's see. Let us see. Um, Peter array. Let's see if we can any of them. NP dot array. The bracket. Um, okay. 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 Let me remove this and let me see. Uh, let's remove this. Okay. Because I want to use the array, but since my data sets are not in array, okay. Let's do this something like this. Okay, since this is not in array, my data set here are not in array. Let me hold this here. Okay, let me try running this and let's see. Um, my data this is not in array. This is not in array, so except I have to make this to be in array. I have to put it in array. Okay, except I have to put it in array. Okay. I don't want to put that in array. So let's just leave that and I wanted to make use of array of color. Except I have to turn this into an array, and I don't want to use the array for that. Except I have to use that array that is y equals to np np dot array and then bracket close bracket all those stops. Okay, except I have to do something like this. I sort of have to do something like this, and I bring something here. Um, I sort of do something like that. I don't want to do all that here. Okay, I don't want to just do all that there. Okay, except I just do things like that. Then I go to then I can come to my color equals to np dot array. Okay, and I see. So 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 we just have some numbers of color. Okay. In here I can have some numbers of color. Let me copy some colors and just paste it inside. Okay, okay, just paste something like this. And let's try running this and x equals to np dot array. And okay, the first quarter np dot array. So I have to just adjust the two data sets. Let me just copy this. Let me copy this, please. Copy this off. And excuse me. Okay, now yeah, then let's copy this here. Okay, now x equals to excuse me, np dot array and this is one, let's see what this is giving me. This object is not callable np dot array. Okay, then the import numpy as um what numpy as np. Okay, import numpy as a, but let's just try that and import numpy np as np. Okay, well, at least object not callable. Okay, then we have x equals to np dot array, np dot array, np dot array let's discuss np dot array x equals to np dot array x equals np dot array bracket will be closed. np equals to np dot array 99 to this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And x equals to list object not callable. 9, 5, 1, 2, 3, 4. Okay. Let's just see